Find the parametric equation of the line passing through the point and parallel to the vector. First we draw the line. This is passing through the point 1, minus 5, 6. We can write this one is the A point. Always we take a general point R. This is coordinate x, y, z. This line parallel to the vector. We take that vector u. This is minus I plus 2j minus 3k. If we see this AR vector parallel to u vector, therefore we can write AR vector equal lambda u. Here lambda is the parameter. AR vector we can write AO vector plus OR vector plus lambda into u vector. We always know OR vector we can write R vector. Then we can write AO vector equal minus OA vector. Therefore this side plus OA vector. Therefore OA vector components 1, minus 5, 6 and plus lambda into u vector components minus 1, 2, minus 3. Therefore we can write 1 minus lambda minus 5 plus 2 lambda 6 minus 3 lambda. Here I write R vector components. Question is parametric equation of the line. Therefore parametric equation of the line we need to write xy components. X equal, this is the x, 1 minus lambda. Y equal minus 5 plus 2 lambda. Z equal 6 minus 3 lambda. Here lambda is the real number. Next question. Find the point in which required the line in part A intersects the coordinate plane. Intersects the points we need to calculate. We need to find the symmetric equation. Therefore first we find the symmetric equation of the line. This one gives the x minus 1 over minus 1, y plus 5 over 2, z minus 6 over minus 3. We take a xy plane. Xy plane, here z equal 0. Therefore we substitute the z equal 0 in the star equation. Therefore x minus 1, y plus y over 2, minus 6 over minus 3. Therefore x minus 1, minus 1, we separate x component and y component, right? Then this gives the 2. Therefore x equal minus 1. Likewise y plus 5 over 2 equal 2. Therefore y equal minus 1. So the required line intersects the xy plane at x equal minus 1, y equal minus 1, z equal 0. Likewise we can take a yz plane. Here x equal 0. Therefore we substitute the star equation x equal 0. Therefore we get minus 1 over minus 1, y plus 5 over 2, z minus 6 over minus 3. Then we separate the y components and z components. This one is equal 1. Therefore y equal minus 3, Likewise, z minus 6 over minus 3 equal 1, z equal 3. So the required line intersects the YZ plane at here x equal 0. Therefore 0, y equal minus 3, z equal 3. Then XZ plane. Here y equal 0. We substitute the y equal 0 in the star. Then we get x equal minus 3 over 2, z equal minus 3 over 2 before the bar, likewise. So the required line intersects XZ plane at minus 3 over 2, 0, minus 3 over 2. Here we need to find the, if they asked intersect the points, first we need to find the symmetric equation, then we need to find the three, xy plane, xz plane, yz plane. Then we substitute z equals 0, x equals 0, y equals 0. Then we can find the intersects coordinate. B part, find the equation of the plane passing through the points minus 1 to 1 contained in the line of the intersection of the plane. They gave the two planes. Before the part, we can do like, first we find the normal vector. We can use n1 and here n2. Then we take a cross product of n1 cross n2. We take a normal cross product of normal vectors if the parallel vector. Then we can find the parallel vector in the plane. Next we substitute z equals 0, z equals 0, those planes. Then we find the another point P node. We already have the A. Therefore AP node vector we can find. Then this is also parallel vector. Therefore we take a cross product of this output and this parallel vector. Both are parallel vector. Therefore cross product of parallel vectors give the normal vector. Then we find the normal vector of the plane. Then we substitute x like this equation. We substitute the output b y minus y naught, z minus z naught equals 0. Here x naught, y naught, z naught equal coordinates of A, like minus 1 to 1. Here A equal this output of Ni, like this one is the A. Ai plus Bj plus Ck. Now we can use another, this way we always using. Now we can use another way. Here we use like this equation. We take this one P1, this one P2 plane. Then we take P1 lambda P2 equal 0. Here lambda is the parameter. Therefore I write x plus y minus 2 plus k into 2x minus y plus 3z minus 1 equal 0. This is already we take. This is lambda. Therefore, this plane passing through the point -1 to 1. Therefore, we substitute the star this point. X equal -1, y equal 2, z equal -1, -2 plus lambda into -2 plus 3 -1 equals 0. Then we find the lambda equal -1. We substitute a star. Then we get x plus y minus z minus 2 minus 1 2x minus y plus 3z minus 1 equals 0. Minus x plus 2y minus 4z equal 1. This is the equation of the plane. This is very simple method. If you are familiar with before the method, you can use that way also. This is very simple, like two equation. Therefore, first we write this equation, then we find the lambda value, then substitute. We can find the lambda value using through the point. Next, C part. Determine whether the planes 2x plus 2yz equal 4 and 6x minus 3y plus 2z equal 5 are parallel or perpendicular or neither. If neither, find the angle between them. First, we find the normal vector of the both plane. N1 equal this equation 2 minus 1. Second plane 6 minus 3 2. Then we take a dot product of those. This give the 2 minus 1 6 minus 3 2 is equal 12 minus 6 minus 2 equal 4. Therefore, this is not perpendicular because this dot product of this one output is not equal 0. We already know definition of the dot product N1 into cos theta. We find the N1, this gives the 9 into 49 cos theta N1 dot into 4. Therefore, cos theta equal 4 over 21. Theta equal, this is the angle between two normal vector. Cos inverse 4 over 21. Therefore, this is also angle between the two planes also. This question they ask, we determine whether the planes are parallel or perpendicular, neither. If neither, find the angle between them. Therefore, this is the angle between the two planes.